Hi everyone. In this presentation, I will introduce you to Link's forecasting decisions. You will understand some of the basic aspects of forecasting within Link's supply chain management simulation game. In Link's, you do short-term and long-term forecasting. Short-term forecasting is meant for the next round, which you do for both products, hyperware and metaware, for both channels, channel 1 and channel 2, and for all the regions within which you're selling the product. Whereas the long-term forecasts are meant for 2 rounds hence and 3 rounds hence. So this is after the next round, few more rounds. How much do you think these products will sell? Your overall forecasting accuracy is based on the numbers that you provide for these different cells within the forecasting worksheet. So in total, you have 16 cells, and your forecasting accuracy is dependent on how much these numbers vary from the actual sales. Your sales forecasts are influenced by your own firm's plans as well as your competitors' strategies. You have to keep that in mind while you're making your sales forecast. Your own firm's plans are in your own control. Specifically, you need to be aware of your generate demand strategies, which have a direct impact on your sales. So you should know what your product offerings are and understand how these offerings influence the sales within the region. You should also know what the service offerings are. What are the prices that you charge relative to the competitors? Along with the generate demand strategies, you should be aware of the supply chain management strategies and their influence on your sales forecast. For example, you should be aware of what your manufacturing finished goods inventories are and what should it mean for your forecast. What is the information technology that you have right now established, and what would it mean for the forecast numbers for the next month? This firm's plan in itself is influenced by consumers and markets. So you should be aware of the size and underlying demand patterns within the markets that you sell. You also should be aware of consumer wants, needs, and priorities. Such information can be obtained with the help of research studies. It can also be obtained by consciously looking at the trends over the course of time to see what exactly is going on in each region with regards to market demand, what is happening with regards to individual products to understand consumer preferences, and so on and so forth. Now, your forecasting has some important supply chain implications. It directly influences your finished goods production. So you need to be taking your sales forecast, your starting finished goods and parts inventories, as well as your inventory strategies, specifically what your safety stock policies are, into account while you are generating your production numbers. Now, these production quantities that you have decided for the company, along with historical sales information that you have, as well as vendor delivery and parts failure rates, would influence the requirements of your replacement parts. As a firm, you're responsible for both your finished goods as well as any replacement parts that will be required for those products. So you need to be aware of your replacement parts, which in some sense is influenced by your sales forecast itself. Now, the replacement parts will influence your supply chain decisions regarding component procurement. So you have to link your sales forecast with both production strategies and quantities, as well as component procurement strategies and quantities. Now let's look at a forecasting problem to get a little bit more in-depth understanding of this. In this problem, we are looking at firm Z that has just completed round 5. They currently sell both products Z1 and Z2 in region 3, both in channel 1 only. To date, firm Z has made only 3 changes to its initial starting position decisions. Now remember, the starting position decisions are the first 3 rounds of decisions that you get when you start making your own decisions from round 4. So they made these 3 changes in region 3, which is our focus. Number 1, they added a DC3 that they have owned and operated since round 4. They added it to try postponement and see what happens. We will learn about postponement later, but right now let's keep this in mind, that they have an owned DC in region 3. They've reduced finished goods and parts inventories to absolute minimums to cut unnecessary costs. They have kept all these different aspects of their firm constant since round number 1. The product configurations have not changed. The channels remain the same. Prices have not changed, and the marketing budgets are also constant. Recent set-top box industry bulletins and some round number 4 research has revealed that some competitors have opened channel 2 for both product lines. They also have observed from these bulletins and research studies that they have reconfigured products. So now the competitive dynamics is changing because there are different kinds of products that are being sold by competitors. Competitors have also changed prices and marketing budgets. Now this table provides us information about their forecasts and actuals for 5 rounds. We also have some additional information. Firm Z's forecasts were just slightly above round number 4 actuals, which we see in the previous table, and they have an explanation for that, which is that we're not making any generate demand changes in this region, so sales probably won't change much. So they have used this logic to consider the changes that they see in the actuals with respect to the forecast. They forecasted increases of 6% and 2% for products Z1 and Z2 respectively. So product Z1 is their hyperware and Z2 is their metaware. Other data from firm Z's round number 4 and number 5 are as follows. You have information about their original manufacturing costs. So alpha, beta, procurement cost and labor cost put together is $102. They also have provided you information about the DC3 finished goods inventory status. So if you notice, this is Z0. Whenever you have a postponed production, here also you have Z0. That product is a postponed product. It's not hyperware, it's not metaware. It can be converted into either of the two, depending on what your sales forecasts are. So you have a beginning inventory of 700 for this postponed product Z0, and planned shipment, which is through surface mode, of 16,200 units. Now with this information about your forecast, about this firm's forecast, about their manufacturing costs and their finished goods inventory status, we have certain things to consider. Let's assume that firm Z ordered exactly the number of Z1 and Z2 products that they forecasted for round number 3. So in round number 3, they had forecasted 15,000 for Z1 and 6,600 units for Z2. So they had actually ordered exactly those numbers. Assume that there were no finished goods inventories for either products at the start of round number 3. So we have to first understand what was the likely cost implication of this underestimation. Notice that the round 3 sales were 15,120 as against 15,000. For product 2 it was 6,930 as against 6,600. So we have to understand what exactly was the cost of this underestimation. Now such underestimation directly impacts the premium that the company has to pay for emergency production and emergency shipment of this production. Now if there wasn't enough procurement inventory on hand, then they would have to also pay premium for emergency procurement. So those are some of the things that you have to account for when you are underestimating your actual sales. So that's what the answer for the first one is. The cost implications are in terms of the costs and the premiums associated with emergency procurement, emergency shipment, and emergency production. Now, the next part of this problem is to finish calculating the percentage changes in actual sales for both products in rounds number 4 and number 5 in the table below. We have to also understand what is something peculiar about this. Do we notice something interesting about demand for each product? So if you look at the percentage change from round 1 to round 2, it is minus 30%. So it's basically you take the actuals 10,500 minus the forecast 15,000 divided by the forecast 15,000. So it's 30% decline and 30% decline for both products. From round 2 to round 3, again you look at the numbers here. So it has been increased from 10,500 to 15,120. So 15,120 minus 10,500 divided by 10,500 gives you a percentage change of 44%. And likewise, you can calculate for Z2, it is 50%. Coming to round number 4, for that, the percentage change is 11,300 minus 15,120 divided by 15,120 for Z1. So let's put this here as round 3 to 4. So if we are calculating it for Z1, it is equal to 11,300 minus 15,120 divided by 15,120, and we can calculate this as a percentage, which gives you minus 25%. In the same way, we can also calculate for Z2, which turns out to be minus 24%. So let's put that here, minus 25%. Oops. And minus 24%. In the same way, we can calculate the percentage change going from round 4 to round 5 by taking 6,000 and then subtracting 11,300 from it and then dividing 11,300. So 6,000 minus 11,300 divided by 11,300 gives you minus 47%. And here you would get minus 38%. So what we see here is that the demand for products Z1 and Z2 tends to vary together. And these swings happen to be quite large. So if you notice, both of them negative and going all of a sudden from negative to positive 44% and 50%, but they both have been changed from negative to positive. So they have a similar sort of trend with regards to their demand patterns. Now 5 rounds is a rather short time period, but if firm Z continues to track this information, they may be able to discern predictable demand patterns. Now, while no demand pattern is guaranteed to last forever, and no two channels can be guaranteed to be the same from region to region or simulation industry to simulation industry, this information may be quite useful for the firm. So that is something which the firm can look at while they're deciding their sales forecasts going forward. The next part of this problem is what appear to be the primary reason for firm Z's lousy round number 5 forecast accuracy. Now, if you notice the description or the explanation that has been provided for their sales forecast numbers within the problem, we see that there's a naive assumption that their sales forecast will only be influenced by their own generate demand strategies. What about competitors? It seems that they have not taken into account potential competitors' strategies. They also didn't seem to consider underlying variability in the demand patterns for this channel in this region. We calculated this in this previous problem. The variability or round to round changes in pure demand in the first 3 rounds of the simulation. Because in the first 3 rounds, all the firms that are there in the industry are at the same level. So if you observe some changes in the demand patterns in those 3 rounds, that should provide you some information about the pure demand pattern that exists within the industry, irrespective of what the competitors are doing. It seems they have not accounted for that while making their sales forecast. Okay, so we could just put considerations for competitor strategies. We would say it's absent, and underlying pure demand trends have not been considered. Let's put this pure in quotes. Are not considered. So those seem to be key issues with their current forecasting strategy. How much product Z0 safety forecast did firm Z have in round number 5? Was this a good decision? Explain. Now, really, they didn't have any safety stock in round number 5. They forecasted that they'd sell 17,400 total units in region 3, and the DC3 finished good inventory report that you see, it shows that they had only 16,900 product Z0s on hand. That's 500 fewer units than they needed to meet their round number 5 sales forecasts. This also indicates that firm Z forgot that surface shipments do not necessarily have 100% of the order available for use in production that round. There is some delay in those shipments when you're using surface shipments. Information is provided in your links manual. This means that those 500 units they needed were probably part of a delayed shipment they received after production at the end of the round. So that's something which they missed out on. Now, in hindsight, it appears to be a good decision because they sold so much fewer than they expected. Their ending inventory would have been much higher had they actually ordered more. Given the apparent variability of demand in this channel, in this region, however, they could probably benefit by considering higher safety stock levels in the future when their understanding of generate demand strategies, competitors, and forecasting improves. So that's some underlying understanding which you can have by looking at these numbers and working out some of these patterns. Okay, so we would just put none, no safety stock was carried. So was it a good decision? I would say in hindsight, yes. But it also suggests the need to consider a few other aspects and also to consider the need for safety stock going forward. Now let's look at this final problem or final subpart of problem where we would be required to calculate the ending inventories. And we will also be looking at what exactly are the cost implications of these inventories. So in this problem, we have firm Z forecasts of unit sales were obviously too high in round number 5. What was the cost impact of this poor forecasting from a DC3 Product Z0 inventory standpoint? Assume a beginning inventory of 700 units and that 16,200 units arrive on time. That's about 93% on-time arrival rate. The original shipments were 17,400. Now, inventory carrying cost is 3% of the value of the inventory. So we will take that while we are calculating. So now, first thing we have to do is, so let's say first we calculate region 3's ending inventory of product Z0 for round 5. Calculate region 3's ending inventories. And this we will do for round 5. Okay. Now the way we do this is we start with the beginning inventories, which we've been told as 700. Okay, so beginning inventory is 700. We add to it any planned shipments. So we have some surface shipments here. So planned shipments that in a surface mode, 16,200. We add any planned shipments through air, if there's any. We should add that. In this case, we don't have any, so we put a 0 here. Plus planned shipments, emergency. Do we have any emergency shipments in the given case, especially if the actual sales happen to be higher than the forecast? Again, that's not the case with this round, so that's 0. Then we subtract postpone production from this inventory, because that inventory is of Z0, which will be converted into Z1 or Z2 by means of postponed production. So minus postponed production, which is exactly equal to the actual sales. Postponed production allows you to respond to the actual sales and in exact quantities as those sales quantities are. So which is minus 9,300. Okay, so this provides you the available inventory as of now. The available inventory, which is equal to 7,600. Okay. Now, this 7,600 available inventory, you take out the planned shipments. You actually add the planned shipments that are delayed. Remember that if there is a delayed shipment because of the surface transportation that you have chosen and the arrival rates that you get, in this case it's 93%, it comes after some time and it adds to the available inventory that you're carrying. So this shipment that you should be receiving later will be equal to the 17,400 that you had ordered, right, minus the 16,200 that you had received earlier, that is this one. So the remaining is 1,200. Okay, so that is something which will come and add to this and which will make your ending inventory equal to 8,800. So that's your ending inventory, which now you can convert into your inventory value and also your carrying cost. So inventory value will be 8,800 times the inventory value which is provided in the starting information within the problem, $102 per unit. So this equals to 897,600. And then plus a 3% inventory carrying cost. That's information that you have in this given problem. So if you add 3% inventory holding cost, that is 897,600 multiplied by 1.03, this gives you the total cost of your inventory, or the total value of your inventory, to be 924,528. Now that's a carrying cost of 26,928, right? That's the difference between 924,528 minus 897,600. And this $26,928 worth of carrying cost is caused by Firm Z's poor forecasts. And that 26,928 and the inventory stored in cash is what Firm Z could not use for other value producing purposes within this round. That is round number 5. So that's the implication of this particular forecasting error. So that's what you should be thinking about when you are forecasting for your own firm as you get into the simulation game and start competing with other companies. I think that provides you some information about how to think about forecasting within Link's supply chain management simulation game. I will be providing some information on inventory tracking, on distribution options, and post-print production later in subsequent presentations. But thank you for listening to this presentation on forecasting.